Hello, everyone. Nice to see there are some few people here with an interest in simulating denim in real time. Quite a niche thing, but also very interesting. I'm Kim. I'm the CTO at Woptag and also the lead developer. And today I will talk a bit about how we approached digitizing denim, because it's a very different thing from most other fabrics. To do that, I have to go through a bit of a crash course in denim treatments. So bear with me. I'll also talk a bit about the benefits of actually doing digitization, and then go into the solution that we came up with. So Woptag is a tech startup based in Denmark, with me as the CTO and lead developer. Our CEO and founder, Patrick Wendt, has about 21 years of experience in the denim industry. And it was his idea on how we would approach this problem, because he knows the denim inside and out. And then he brought on me as the developer, and we just kind of took it from there. So over the past almost 2 years, we've been grinding at this thing, and now we're at the point where we can release in a month or two. Our target user base are everything from the denim mills themselves to brands or anything between. What we made is a simulation software in Unreal, and I will showcase it in a bit. So the current state of fabric digitization is kind of interesting. It has mostly been what you would consider to be solved, except for the denim part. The workflow goes like this. You create a physical sample of the fabric. You scan it or photograph it using some service provider. And then at the end of this, you get a PBR texture set with a diffuse map, normal map, roughness map, and so on. This works pretty well for most fabrics. And some examples of providers for this service, for example, you have Viso, which is using a scanner, I think. Bandicoot Imaging gives you kind of a kit to set up a camera and color correct it and everything and get the right color balance and lighting, so you can do it yourself. And then we have something like Jamel, for example, who is doing fully digital procedural with their own proprietary software. And yeah, why it works. Most fabrics don't really change much from the moment they're created to the point where they're sold as a garment in the store. Due to the structure of most fabrics, there's no visible, obvious patterns to the naked eye. So you can easily tile them, and you don't need big sample sizes either. You can keep them fairly small. And the colors you get out of a scanner or photograph are good enough. They're accurate enough to the point where you can use it in marketing materials or even visual production and stuff like that. Now, why it doesn't work for denim is a completely different story. Because not only does denim change a lot from the point of fabric to garment, it's actually the most important thing about denim to get the correct look. There are a lot of involved techniques that you need to be aware of when you're doing denim development, and simulating that digitally is really difficult. So, crash course begins. Commonly used denim treatments range from washing, for example, where you take a bunch of garments, you put them in a washing machine, and you do maybe a rinse wash where you remove some of the indigo dye at the top. Then you might do a different washing with some enzyme blended in. Then you might do a different wash with some stones blended in, like the show here, which gives a unique structure and a unique look to the fabric. And during this washing, since you have all these garments together in the washing machine, they rub against each other, and all the areas that are double folded like this and where there are seams, they're a bit stiffer than the rest of the garments, so they create these abrasion patterns. So the brighter areas are areas where the fabric is pointing up or kind of folded upwards, and the darker areas are areas where the fabric is folded downwards. So the ones that are folded upwards get more, they rub together much more than the rest, so you get these very nice looking patterns. You can also do bleach treatments, where you mix in some bleach, and depending on how much you mix in and how long you wash it, you will get varying results. You can get from this rinse wash here on the left to a very, very bleached wash on the right. There are also some special treatments. You can mix in some acid to get some pretty cool looking patterns. You can use different techniques to destroy the fabric. So during the washing, they expose the underlying weft, for example, and you get these fluffy parts around it. That's the result of the washing and the rubbing together as well. You can tint it with certain chemicals to get usually a more yellowish look of it, if that's what you want. And you can also do something called net washing, where you take a bunch of fabrics, you put them in a net, throw them in the washer, and abrasion from that one creates these organic, semi-random patterns on the wash. You can also do things like manual abrasion, using, for example, sandpaper to create these designs. And these designs are meant to emulate the natural wear and tear pattern when you wear a pair of jeans for a long time, you sit down, you walk around. These will appear organically, but it would take too much time to do this for all garments, so you do it with sandpaper or, in certain cases, laser machines as well. And here they're using a grinder to produce some destroy effects on some minor details as well. So it's very involved, it takes a lot of time, and you need to know what you're doing to get good results on this. Much cooler thing is the laser treatments, where they basically take a strong laser and they take some sort of input map to the garment, run it through, and you create these wear effects much faster than with manual methods. And here is an example of a full leg being made. So first they apply the laser design. And here they pump up the strength a lot to really burn. You get these effects afterwards when you wash it. So here you see very strong laser. So yeah, this also takes quite some time to do a full garment, but it's way faster than doing it by hand. Now, the issue is, with current digitization techniques, you can't really replicate this easily, at least not realistically. You usually do things like you take a small sample of a fabric, you tile it, you put it in some software, and then you layer on top some different designs, some laser designs or abrasion patterns like you see here on the waistband. But the blending itself isn't actually physically correct. Those colors is not what you would see in the actual fabric. You can use different blending techniques like overlay or linear light or whatever, but the result won't be accurate. So what you're left with is, at the best, an artistic representation, and at worst, just basic guesswork. You can't really use that in production, for example, because you need to know exactly what you're getting out of it at the end. Because it's all in the colors when it comes to denim. If you talk to a denim person, they will tell you this right away. They're very proud of their indigo recipes. Trade secrets, they don't want to share this. And if you don't represent that color accurately, there's really no use for it for production at all. And that's really, really important when you apply these different designs on the fabric, because if you don't get that, then what's the point, really? So if we could do this, the benefits in terms of environmental impact is quite large. If you ask someone about the environmental impact of creating jeans, you will get answers ranging from it's pretty bad to it's apocalyptic, basically. So if we can reduce this as much as possible, that would be great. According to United Nations Environment Program, it requires about 3,800 liters of water to create a pair of jeans. Now, most of that water is during growing the crops and stuff like that. But about 10–20% or so is during the washing treatments and stuff like that. And the big issue with that is that that water isn't pure. It's filled with chemicals, and then it's dumped outside in nature, and it goes into the ecosystem and does all kinds of damage. So we don't want that. Also, a lot of CO2 is released. I think about 50% of those 33 kilos is released during growing the crops and creating the fabric itself. And the other 50% is during production of the actual garment and shipping and whatever else you have. And that's not all, because when you create a new line for new jeans, for example, you don't just create it right away. You do a lot of trials. And these trials are also very lengthy, very involved. And it's not performed at the same place. It usually you create some physical samples in Asia or wherever, and you ship it over to the US or Europe for improvement or for feedback or something else. You send back the feedback, they create some new ones. Maybe you got the laser design a little bit incorrectly, so you need to do it all over again. So yeah, this can be done, or is being done globally, probably thousands of times over the entire fashion industry. So we obviously don't want that. Another big issue is waste. Due to how you cut out the patterns from fabrics, you're left with a lot of pieces of fabric that you can't use. And these pieces end up in landfills or they're being incinerated, neither of which is particularly good for the environment. You can't really avoid this just due to geometry and stuff like that. So if we can just end up making less garments, that would reduce the waste as well. So yeah, the benefits, of course, reduced emissions, reduced waste, but also things like reduced costs. You don't need to buy or produce as much fabrics. You don't need to go through the entire process of creating all these samples, shipping them, all the other things, approval and sending back. It's a lengthy process, and if at any point during this process something is incorrect, you need to start over. There's no like saving your progress or anything. You just need to do it again. So doing it digital will also mean that you could increase the efficiency. Like you could quickly iterate over designs and change on the fly, and you can sit together in a room together or looking at the digital and say, yeah, can we try a different laser design or something? Can we bring in a new garment to see this fabric on? So it will be very streamlined to do it without having to do the physical samples to iterate on. Okay, so with the crash course over, I hope you learned something. Let's talk a bit about Woptag and what our application is doing. So we built it on Unreal Engine 5. It's fully in the engine. When we started, we tried some different things. We started in Blender, trying to find out a good workflow. Quickly realized that building our own custom fork of Blender and then telling a mill to compile it themselves and teaching someone there to do Blender wouldn't work. You can't really put that much effort into teaching someone a new software. Because they usually have these very strict pipelines anyway, so you need to find a way to kind of fit in there. So we looked at Unreal Engine 5 due to the many real-time properties that it has. And we saw a lot of things like visualizing cars and visualizing fashion, for example. So we said, yeah, let's try this one. Because we figured at least we can make a prototype. And from there, maybe we can do something else. But we kind of, over time, decided, let's just keep it in Unreal because it's so simple and efficient, and it works for our needs exactly. Due to this, we support really high-res textures. And that is super important because when it comes to the denim, there's a lot of details you need to capture. When you do the regular fabric digitization processes, you work at 300 to 600 dpi, which works fine if you don't need to actually change any of the structural colors of the fabric. But for our needs, we needed to go up to 900 to 1200 dpi. And sometimes we even do anything from A4 size scans to, we tried one which was 1.5 meter by 120 meter or something at 1200 dpi. Worked really well, no problem. And one other thing we could do with Unreal Engine was that we could create a workflow in a UI that emulates the actual processes of a laundry. So one of the goals was to being able to take our application, give it to someone in the industry, and with minimal training, just say, you recognize this, these are things you know, just do it here instead, basically. Found great success with that. We got a lot of good feedbacks about it. So I feel like we're in the right way in that sense. So how do we actually do it then? So, like we said, we created something we call the PGF. It is a container file which contains a bunch of different things that are needed to simulate this. First of all, it's a fabric scan that can be done with a regular scanner, as long as it supports 900 to 1200 dpi. So if you want to do bigger scans, you would have to have a flatbed scanner or something like that, but that would also be supported. The other thing is that since we're handling the colors separately from the fabric or from the scan, the actual color of the scan doesn't really matter that much. It doesn't have to be color calibrated or anything because we don't use those colors anyway. Instead, we extract those color values either ourselves or ideally we get them from the mill because they have access to a wide range of their indigo dye recipes and the color values that are associated with it. And we use the LAB color space, which is very easy to work with and it's very easy to use and extrapolate colors and stuff like that. So we found great success with that one. And then the last piece of the puzzle for us was use of AI. Not in a generative sense or anything like that, but we created a machine learning algorithm to take the scan, take the colors, and transform them into textures and color values that we can use in Unreal. This was a pretty lengthy process, but we got there in the end. It was really interesting because we did it all by hand first. We tried, what happens if we transform the colors like this and transform the texture like this? And then once we had something that worked, we said, okay, maybe there are some patterns in this. So we started looking at it and we realized that a machine learning algorithm could probably do this much better than we can. And yeah, it turns out that it can. So that was the final piece. And with these three components, we have the PGF. So besides the PGF, we need some certain maps, we call them. Usually you can get these from Clo. There are things like the aberration map at the top left. We have a darkness map on the top right. These two together basically simulates the aberration patterns, the high and lows of the puckering and stuff like that. Down left is an edgeware map, we call it, which is targeting only edges where there are folds, or where the fabric folds together and where there are seams and things like that, because those areas always get a lot of aberrations compared to the rest. And then on the bottom right, we have an example of a laser map. So this is a laser design. We did it in Clo as well. And we can import that. We support multiples. So if you want to combine them or see what happens if you bring in two different ones, or if you want to see, for example, you can split them up in having one texture map for just the front parts and a different one for the back parts. If you want different strengths, for example, of the laser, you can do that. But you can also create these maps yourself in Photoshop or any other software that supports this. It doesn't have to be Clo. Next up is the integration, which is really important. So the workflow right now is that you create your garment in Clo or Browseware or any other 3D software with these maps and everything. You then import it into Woptag as an OBJ file, for example, or an FBX. Those are the two types you support at the moment, but we're looking into things like GLB files, for example. And then you apply your PGF, which you probably have already, and then you can start washing. So we show a quick demonstration of how the import process is. It's kind of streamlined right now, and it's still in development, but this is the basic workflow of it. So we have categories, we have the meshes, we have the texture maps, and we have the PGFs. So you select a folder with the meshes. Can be multiple, it doesn't matter, can be one. Then you select a texture map folder with all the aberration maps and the darkness maps and the laser designs and whatever else. And you select a PGF. You can also switch out this PGF on the go in the simulation scene if you want to try a different fabric. The same thing with the texture maps. You can just switch them out on the go and try different things. Here it's loading everything in, and then you get a new view where you can, these are the materials associated with the mesh that we just imported. So you can assign different categories to them. So we have denim, we have the inside fabric, we have buttons, for example, rivets. We have one for graphics, in case you have labels or stuff like that, you might want to apply to it. Seams you don't have to apply here, it will be automatically applied to anything that hasn't a category associated with it. Here on the right, we select the different maps, so the aberration map, edgeware map, dark map. If you have a destroy map for ripping and tearing or whatever else, you can import that as well. And then 2 laser designs are imported here. Yeah, once you're done, you just apply everything, and then you're good to go. So now it's loading everything in, applying all the materials, and then you get to this scene with your garment and the PGF applied to it, ready to start washing immediately. So a quick washing demonstration. Now keep in mind, I'm not a denim designer, so this is just me playing around a bit. But just to showcase kind of what you can do and how quickly it works and how quickly you can iterate on designs and try different things. So the UI down here, this is the wet area, we call it. This emulates the washing machine processes. So all the wet processes involved in denim treatments, these are controls for that one. And we have, for example, rinse, enzyme, and stone enzyme. So this would be the first wash you do, which affects it very little. An enzyme wash affects it much more. It brings out much more brighter colors in the fabric. And the stone enzyme, even more so. We also have stone wash, which emulates the stones inside the washing machine if you want to have those. Here I'm adjusting the different maps we imported, so the edgewear map, the abrasion map, the dark area map. And they combine together and they work in different ways based on the type they are, basically. So the dark map makes everything darker, and so on. Then here we have the laser slots, we call them. Can load in 3 at the moment, but we plan on supporting much more. So this works in a different way from all the other maps, because this is affecting in a certain way based on how a laser would affect the fabric. Here's also an example of our path tracer running. So we can enable it and disable it on the go whenever we want to. And of course, if you do the path tracing view, you have much more accurate lighting and colors and stuff like that. So when you do your final treatment, you usually go into path tracing and check it out like that. And also with path tracing enabled, you can do renders directly in the app. We support resolution of your native resolution ×2, ×4, and ×6, if you really want a lot of details there. Here I'm playing a bit with the bleach to get a more bleach look, and also the gray cast, which basically removes blue from it and makes it more grayer and less saturated, which is also a process that can be done in a laundry. So yeah, very quickly you can iterate and try new things without having to do much work at all. And then here we also have a different thing we can do in terms of exporting. So if you don't want to render it out in Woptag, you can export these washed textures as a PBR set. So here I'm showing the resolution and the render button. But we also have the PBR, like I said. So if you go there, you can export these textures as a full PBR set with diffuse map, normal map, displacement map, and roughness map in whatever resolution you have up to 16K. So here it's exporting. And now it's done. So now you have a texture set of this exact wash that you can use wherever else you want. And if you want to export a new one, you just create a new wash, do the same process again, and just export it. So here I'm creating a stone enzyme with a bit of gray cast. And I say, yes, this is what I want. I export this one as well. And then it goes through the same process again, and at the end you have 2 different PBR sets with 2 different washes. So a little bit about parameters again. I kind of brushed over them really quickly, but on the left here with the rinse enzyme and stone enzyme, those are also the stone wash in one sense. Those are the washing processes in the washing machine, right? So rinse would, like I said, affect the color very little. It would make it a bit brighter than the raw denim. The enzyme much more, and the stone enzyme much, much more. And the stone wash just emulates these stones hitting the surface and creating some nice, brighter areas at the top of the surface. Bleach, super bleach are two different types of bleaching. One goes mostly on the top, and the other one goes mostly at the bottom of the fabric. When I say bottom of the fabric, I mean the bottom of the actual structure of the fabric, not the bottom of your pants or anything. Tinting, if you want to apply some tint to it. Gray cast, if you want to make it less saturated. And this surface adjustment is a control for how much should it affect on the top of the surface compared to the bottom. So you can kind of control that as well, because certain fabrics, when you wash them, will change their structure quite a bit and become less contrast inside the top and bottom, basically. So you can adjust that there with that one as well. And then the enzyme effect. Basically, you can, when you mix in some enzyme, you usually get some natural organic patterns all over your wash, and we can simulate that with that one as well. This one, the FX area we call it, with all the maps included. You saw these ones in action on the left. The random wash is something that happens naturally as well, where certain areas of the garment gets more abrasion than others, even beyond the abrasion parts. So we can simulate that as well. And we have a seed pattern, or a seed for the pattern, which gives you as many different designs as you want, basically. Dry areas for things like the laser and manual abrasion. Destroy effect, if you have a destroy map imported, you can enable that one there, and you will get some transparency in the garment, and you can see how it would look like in real life. And the other two, this one is just for if you have a certain type of texture that doesn't work well, you might adjust the blending here to get it look better, basically. Scraping effect is something if you have a laser design that you want to see how it would look like if you actually did it by hand instead of with a laser machine. You can enable that one, and you have some settings here. You can adjust the, it will basically emulate the type of sandpaper you use, for example. And here are some renders we did in our application with the path tracer. So just some few examples of what we can do. Here's a very bleached one. This is the same one as the one before, but the full garment. This is a pretty dark enzyme wash with a lot of abrasion on the bottom, and here is some laser applied to the back side of the leg. Here's one of a jacket. A lot of abrasion going on at the edges here. Here's the same jacket with a different wash, a bit brighter. Here's an example. Here's a comparison of a non-gray cast wash compared to a gray cast with 50%. So there is quite a bit of a difference. And sometimes you want this look, so it's important to have that as a feature. We also tried some just different laser design to see what we could do. This isn't really realistic. You would never have a laser design this strong on something this dark. But if you want to see what it would look like, you could do something like this. Also tried importing some different textures so to see what we could get. All over laser designs we can do. We can combine different laser designs. So for example, here we have a standard one, which affects these parts here and these parts down here. We also have this repeating pattern over here, and then we have a third texture here, which is basically inverted. So the actual wash of the garment here would be this dark area, and the rest is just brought up by the other laser textures. Some more examples of different laser designs. Like I said, these are pictures we just threw in, see what happens, and if it looks good, it looks good. So besides the rendering, like I show here, you can also create this texture set that I talked about. Any software that supports the standard PBR workflow with these different maps, you can use them in. We also have presets, so you can save your wash settings, and if anyone else has Woptag and they want to share these settings, they can just send over the PDF, send over the settings, and they will see the exact same thing as you do, And from there, you can discuss it together or make a decision based on that. So beyond our application, what can you do with it, right? So you can, like I said, you can export them as a PBR texture set, use them in Unreal Engine yourself or in Twinmotion. You can import them back into Clo if you want to see how they look there. Use them in Blender, Cinema 4D, 3ds Max, Maya, whatever else that supports PBR. But the one thing we found was Twinmotion. We worked all morning together with them to create a bunch of different washes and set up a nice scene together. So if you're interested in seeing what you can get out of Woptag, come down to the Twinmotion booth. We will have some nice things there if you want to see what it looks like. I will also be there if you have any questions or something like that, or if you just want to grab a coffee and have a chat or something, I'll be available. But this works really well because Twinmotion supports these high-resolution textures. So when we export, for example, a 16K texture, which is the biggest one we support in Woptag at the moment, you really see the details in Twinmotion. So very nice, very easy workflow, and that's kind of what we would recommend going forward. Now, I kept this fairly general. If you have any technical questions or anything like that, I would be happy to answer them. But other than that, I want to say thank you. Hope you learned something and found it interesting. Thanks.